Welcome back to the channel. Here we go. We're going to work on nomenclature. More importantly, the resources required to be successful with nomenclature, naming, and writing formulas. So we'll look at a couple of things, and then the next videos will be about ionic compounds and acids and covalent molecules. Okay, so we're going to talk about the periodic table, and using it as your main resource helps you to identify how to write formulas and how to name substances. And then you have polyatomic ions. There's a long list of polyatomic ions, but we'll talk about a few of them that come up quite frequently in labs and in naming and writing formulas. And then the last thing that we'll talk about will be diatomic molecules. Okay, so when we look at the periodic table, the first thing we want to talk about are the physical states. Physical states don't necessarily change how you name a substance, but it's helpful to understand what physical states we have. So you have solids, liquids, and gas. The majority of your elements are going to be solids. You have mercury and bromine, which are liquids, and then you also have gases. So those are the physical states of your elements. Next, you have types of elements. Types of elements would be your metals, nonmetals, and metalloids. Knowing where the metals, nonmetals, and metalloids are located on the periodic table is helpful when you're dealing with nomenclature because of rules that you want to follow. Up next, you have the atom. The atom is a neutral element that has equal parts protons and electrons. So we see in our example here, you have sodium with 11 protons and electrons, and then chlorine with 17 protons and electrons. When you want to form a substance, you need an ion. An ion is going to have either more protons or more electrons. With sodium here, you have 10 electrons, so it has one more proton, making it a cation, and chlorine has 18 electrons, so more electrons, and fewer protons, that makes it an anion. It's helpful to understand cations and anions because when you are doing your bonding, you have your cations, which are primarily metals, your anions, which are primarily nonmetals. When they bond together, you form ionic compounds. They are donating electrons. That's how you get more protons or electrons from the neutral atom. Knowing how the electrons are donated brings us to our charges. So you have charges for every group on the periodic table. Group 1, you have your +1 charges. Group 2, +2 charges. You have the inner transition metals, which are not used frequently, but you do have the +3 charge. Then you have the group with boron. Most of the time they're going to give you a +3. Carbon group, they'll give you a +4. Your transition metals are tricky. They have various charges. Some of them have multiple charges, where you have silver with a +1 charge and zinc with a +2 charge. Your anions are going to be -3, where the nitrogen group is. Then your oxygen will have -2. Your halogens will be -1. And the noble gases have no charges. And those are going to be used to make ionic compounds. If there's anything that you need to memorize on the periodic table, it would be these charges. Knowing the charges of your elements is based on where they're located on the periodic table. So if you know where everything is located on the periodic table, you remember which group is associated with which charge, then naming and writing formulas will not be a challenge for you. As I mentioned earlier, there are a lot of polyatomic ions, but there are several that are very common here. So the only cation that I have my students memorize is the ammonium ion, and it is NH4 with a +1 charge. And then you have hydroxide and chlorate. If you have an 8 and an 8, the 8 will always have more oxygen than the 8. So here you see nitrate, NO3, nitrite, NO2, and they both have a -1 charge. You have sulfate and sulfite. Sulfate has more oxygen. It has SO4, -2 charge. Sulfite, SO3, -2 charge. And then lastly on this list, you have carbonate and phosphate. Carbonate is CO3 with a 2-, and then you have phosphate, which is PO4, 2- or -2. Those are polyatomics that you want to memorize. The last thing you want to do to make sure that you are successful in nomenclature is to learn the diatomic molecules. There are 7 diatomic molecules that exist on the periodic table. And if you look at the periodic table where they're located, they make a wonderful little 7. You have nitrogen and oxygen, and then all the halogens, and that's 6 atoms. Then you add hydrogen, and you have 7. To write the formula, it's just a subscript of 2. So they're 2 atom molecules that share electrons. That's why they're called diatomic molecules. This is their formula. These are their names. With all of this, you should be successful in nomenclature. If you need more practice, come back for the next lesson.